So these guides, along with good process, all of a sudden, high performance is easy.
You know, this rethink towards net zero is rethinking a lot of the traditional building enclosure assemblies and building them better.
I get excited, but I also get depressed. I'm depressed because I'm old. And if I was younger, I would embrace this opportunity for this change. I see the young builders, and to me, I get excited for them. Morning, Graham.
Morning.
Yeah.
Hey, James, how you doing today?
I'm all right, Graham. You?
Good, good. I see you built us here a little mock-up
I
here.
did.
Can you tell us about it?
Yeah. It's a split insulated wall assembly, pretty traditional. It starts with an ICF foundation, bad insulation on the inside with drywall and vapor barrier paint. So, you know, pretty traditional stuff. 2x6 framing. On the outboard side, I have 5 inches of foam. That's the split insulated assembly. The foam is grooved, and we'll get into that. But as far as the assembly goes, standard headers, and then I have a vented attic space. So again, nothing unusual. Same old wall assemblies, but a little more high performance. Here on the outside, I have, to spin that so you can have a little better look at what's going on. You can see it's just a rain screen cladding, strapping and cladding system. Pretty traditional, okay? And that's what I built for you to talk about.
Great. Let's dive right in.
Dive away.
So we've got our LEAP Wall System 3 here represented in this mock-up. And as you mentioned, we've got 5 inches of EPS
That's
foam
correct, yeah.
insulation over a 2x6 wall with
Correct.
a house wrap, air and water resistant barrier. So we're about our mid R30s, right about R35 or so for this assembly. So from a water control standpoint, we've got our cladding, and we got our water shedding surface. And how are we controlling water with this insulation here?
So a couple of things have been considered here due to the nature of the insulation and the wall types, and there's a whole thing that we can get into a bit deeper, but it's a traditional approach where I used to use a sheathing membrane,
Yeah.
which that's what we do,
Yeah.
and that's the air and water control layer, okay? And the same thing applies, obviously, in the bottom half. The interesting thing is the insulation itself is actually grooved on the backside to allow for considerations of moisture within the wall assembly. Very simple.
Do you want to show us some of that
Yeah,
insulation?
I got a piece here.
Yeah.
I got a piece here, and many types, but that's it in its basic form. So,
Yeah. So we've got, you know, standard EPS, but we got grooves that are being cut in
and there's
here.
lots of different types of groove patterns,
Yeah.
but the point is just a place that can handle moisture.
Yeah. So what's unique about this assembly is we got a rain screen, but we got our foam insulation in our cavity over our house wrap, but we've got drainage behind the insulation. So if any water gets in during construction or in service, it can drain out.
And you know what? There's other ways you can do that. Let me show you something else I brought. If you don't have grooved insulation, you can use a very fine drain mat that would be attached to the wall and the insulation installed over. You can attach that with maybe stainless steel staples, tack it on, install the insulation. So the point is consideration to control moisture that could potentially end up behind there.
And that's great because there are a number of builders that are concerned about putting foam plastic on the outside of wood framing, and this provides that buffer to allow an impermeable insulation to be drained and the water to get back out.
Yeah, very much so. And there's just a lot to that, and I guess we're going to get into a little deeper discussion on that, but you know, how much are you putting on? All these things, where are you building it? All this comes into play. This allows you the flexibility to build a traditional split insulated wall with foam plastic. That's why I built this.
Yeah, this is great. Yeah, so we've got, and when we look at this assembly here, we've got quite a bit of insulation on the outside. It's a lot different
5
than,
inches.
you know, tradition, maybe a more conventional approach, maybe only a couple inches or so.
Yeah.
So we've got enough insulation on the outside here, so the ratio is quite high. So we've got, you know, about R20 here and about R20 here, so we've got a 50-50 or so split.
Yeah, exactly.
Which in most places is going to essentially push your dew point into the outside of your wood frame assembly. But also keep the temperature here warm enough that you don't have a risk of condensation, but also warm enough that it can dry out.
That's correct.
I also noticed that you don't have a vapor barrier in the inside. So what have you done here?
You know, on the back side of the wall assembly, you can see here, there's a vapor barrier paint on the gypsum, okay, as a measure of managing the interior to outside vapor drive, okay? It also can allow some back drive and drying because it's a retarder. Didn't want to put poly in this assembly with foam on the outside. Okay,
Yeah.
it's just not necessary, and it elevates unnecessary risk.
That's great. So if we look here, so we got a vapor retarder paint that controls the vapor diffusion through that assembly, but also allows it to dry back out.
Yes.
And what's really neat about this too, with this ratio of insulation, is we all actually in a situation we might not even need a vapor retarder anymore.
Maybe.
And so if we actually put in maybe a bit more, or we're in a drier climate, we don't even need to worry about a special paint.
This then becomes the control
Yeah,
element.
yeah, and the sheathing and the foam itself.
Yep.
Now, instead of vapor retarder paint, I've heard some concerns from building inspectors that they can't see it, so they want to see something.
Is it there?
Right.
Yeah.
So yeah, and poly is so traditional, but the poly is the wrong thing here. You don't want to put poly on the inside of this wall with the foam on the outside, because if water ever gets in, then it can't dry out, or it's built in, right?
That's right.
So there are other products like smart vapor retarders. Would that work here?
That would absolutely work here.
Yeah.
And it's an excellent point that you make, that if you can't see it, is it there, right?
Yeah.
And one of the things about a vapor retarder paint is it's a function of area coverage. And when people get paint, the traditional approach is stretch it as far as possible.
Yeah.
That does not work for vapor paint. It's set area coverage per volume
Yeah.
that makes its performance characteristic. So having a sheet good, a pre-manufactured approach to a smart vapor barrier that allows that
Yeah.
a little bit of drying and resistance in the directions necessary is a good way to go, and a simple approach.
Great. So we got our vapor control, we got our insulation, the air barrier in this assembly. I like how you've chosen a traditional approach. You got house wrap,
Yeah.
which is taped and sealed. You can't really see it in this mock-up, but we got our house wrap as the air barrier, and the guide goes through all the details and
Yeah,
walks
all the
through
joints are taped.
Yeah.
The traditional approach for an exterior
Yeah.
synthetic sheathing membrane.
Yeah, so house wrap's a good choice, and we'll get into some of the details in a minute. But what else could you use here? Could you tape the plywood in this case here?
If you wanted that air barrier approach, of course you could.
Yeah.
That's a really tremendously excellent air barrier. But when you put a synthetic sheathing membrane on, not only is it simple, requires less tape, and you have a compressive element against it,
Yeah.
you really get a tremendous air barrier.
Yeah.
So if you want to keep it simple, just use a synthetic membrane, in my opinion. That's why I built this way. You could tape all the plywood joints, but what's interesting is when you get down to doing that, you realize, holy cow, there's a lot of joints. Okay, it's not the same with the Tyvek. It comes in 9-foot rolls. You can cut it to whatever size you want, and you can install it in a manner that minimizes the joints. Because what leaks is the joints.
Yeah.
The plywood's airtight, the tape's airtight.
Yeah,
The
exactly.
synthetic membrane's airtight, the tape's airtight, but you still get air leakage. What's leaking? The joints. Okay.
That's right. Yeah, so we got house wrap, pretty traditional approach. We could use self-adhered versions. We could tape. We need
Yeah.
water control back here, though. We got to remember that because we're potentially allowing water, and we've got that drainage. We have water control and air control. And as we're detailing everything back here, we have flashings. We got flashing here above the window head, which we need by code.
But not metal.
Yeah,
And so the
that's
code
right.
indicates, and I have this discussion with builders lots of times, is, well, you got to put flashing in, that's metal.
Yeah.
It's not metal. The code makes it clear that it is a membrane. Even understanding roofing practice, talk to a roofer or flashing,
Yeah.
it's a membrane, not a metal, okay?
Yeah.
And you don't want to stick the metal through here for that thermal bridge.
That's right.
It wouldn't be necessary. It's also inherently difficult. The flashing is a water shedding element, okay? It's intended to bring any moisture that may come and bring it out. It's not intended to be stitched into your air barrier.
Yeah.
Because it's not part of the air barrier.
It makes it way easier to detail this too.
You put your air control layer on,
Yeah.
run the membrane back over from the air barrier, so you're marrying membrane to membrane.
Yeah.
It's a much simpler approach. Put the metal on the outside for the deflection, the back leg stops right here. And so that's why I built it this way. It was not only simple, I'll show you something. It actually functions as intended.
It's a lot of water. Wow, look at it come out there.
And the water drains out.
Wow.
And so that's what was intended.
That's amazing. That works really well, James. So we've got our air barrier. We have other choices other than house wrap, but we have our air barrier here, and we got to think about the continuity, right? So let's start down in the grade here.
Sure.
Got our ICF foundation. And
Yes.
an ICF, what do you think is the most airtight?
Well, you got a couple of things to consider when you do an ICF. You can have and they make waterproof membranes intended to go outside that foam.
Yeah,
And that
right
can
here.
be integrated into whatever your floor slab air barrier system is. We're not going to get into that, but you need continuity. Everybody knows that, right?
Yep.
Barriers must be conducive. So if I had a membrane run up the ICF, I could integrate that membrane with my air barrier here
That's
by
right,
way
just
of
by
a
lapping.
Flashing membrane.
Flashing, yeah. So we got our peel and stick. So we
Right.
got our air barrier, whether it's the membrane on the outside or it's touching into the concrete
Right.
here as well. So we got air barrier continuity from the below grade to above grade on the outside, tracing it up.
But there's one other consideration for ICF that must not be overlooked. If you don't have an appropriate waterproof membrane on the outside of that, you need to lock to the core.
Yes.
The concrete core
That's
would be
right.
the airtight
You
element
need to
then,
get-
okay?
You need to actually have a bit of, you'd have lap in there, or you'd have to, potentially even pull the framing back in to get seal right to the
Run the membrane through, whatever you need to do to make that connection from the foam back out to the outside. So you can run a membrane, whatever you need to do. But when you build these types of walls or, this here assembly or any assembly, you need to be able to track those barriers.
Yeah. So we're tracking the barrier up. We'll get back to the window here in a
Mm-hmm.
minute with the window details. But the window, the air barrier from the wall goes into the window. It goes into our back dam, goes through the window itself, up through.
And it's connected here with sealant,
Yeah,
okay, at the
that's
back
right.
down.
Yeah, it's very important. Yeah, you seal that up. And we'll get into some of the alternates here in a bit because a lot of questions about window details and what's the best way to do the sill with exterior insulation. We'll come back to that in a second here.
And the sequence of construction.
Yeah,
that
definitely.
plays.
Yeah, definitely. So we've got our house wrap through at the head, the sealant up to the head, up here. And so what's going on up here? I noticed we got some
Yeah.
we got some tape, we got some
So, you want me to get into this? I'll get into this a little bit then, okay.
Let's get into it.
So, when you need to transfer an air barrier from the outside
To this on the inside.
to the poly by default, PVD as I like to call it, poly by default, the PVD here, because you have a vented roof,
Yep.
this is your air and vapor control,
Definitely.
which must connect. So these two must connect. This piece of wood, do you think you could blow through that if I held up a 2x6? Could you make my hair move?
I think
you
you
could
could.
make my hair move with a hair dryer, okay? Anyway, but you can't blow through this plate.
Yep.
Okay? So if I can connect this Tyvek air barrier in this case
Yep.
to this plate, I have a connection. How do I
Yes.
do that?
Yeah.
I take a high performance tape. This high performance tape would, well, that's interesting, would come across from the plate, across here, and down like this.
So you definitely have to do that before the foam's on, right?
Well,
You
no,
gotta think-
yes, and the key that I can't tell you how many times I get a call to give a hand, and I come to the site and the trusses are on.
Yeah.
Okay,
that's
it's
too
like,
late.
oh my goodness, you need to install this while you're waiting for your trusses. And you know what's really interesting about sequence construction is when you're waiting for the trusses, what do you have? Well, this built-in scaffolding around the inside there,
Yeah.
all ready to go because we don't walk the plates anymore. At least I hope we don't because safety's first, okay? And so you have the scaffolding. It's right here, your top plates.
Yeah.
You can walk around with a high-performance tape in a
Easy.
matter of a couple hours and ring that building.
Just tape the top and so you transfer
Tape
it
right
into
here
the
from the
plate.
plywood,
And then what do you
to
do
the
with
plate.
and joints between the plates here? What do you
and
do?
then you run a piece of tape across each joint.
Yeah.
So at the end of it, you have this monolithic top plate,
Yeah.
all connected to the plywood on the outside. So when you bring the Tyvek up,
Yeah.
I can simply tape the Tyvek to the receiver tape,
Yeah.
and I'm now connected across there. I had nothing in my way, no joists, no nothing. The problem is when people are trying to build this is they always think about this after the trusses.
Mm-hmm.
The key to success of building this, and even others that I build sometimes, wall like this, is just a simple plan.
Mm-hmm.
And that's all we need to do to build a LEAP wall
Yeah.
is have a simple plan, because everything you see here, it's already on site.
So, and so we got tape. So obviously we need a tape that might stick to damp wood. So
Yeah.
pick the right tape, not probably the red tape. It's probably a
Red
good tape.
tape is a sheathing tape. It
not
is
a
made
fun
for
for- not for
plastic
wood- not for
membranes.
wood, yeah.
Not plastic, not appropriate.
What if you could also put a piece of peel and stick across the top of here if I
I
wanted
wouldn't.
to?
I wouldn't, because I prefer to have as much drying ability
There you go.
during the course of construction. You can't judge how much wetness you get.
Yeah.
But the tape I choose
Yeah.
for this here happens to have 1.72 perm
And
rating,
it's covering a small area too.
and it bonds to wet wood.
Yeah, and so so we got the tape method.
Yep.
Could do peel and stick. We don't necessarily need it.
Yep.
You could also transfer through with sealant here, but you have to get sealant your framer to put sealant
Well,
in between your sheathing and your.
Let's
and
talk
framing.
about the sequence of construction then, okay?
Yeah, it's hard to do, right?
They frame in the rain,
Mm-hmm.
and they frame. I don't know too many framers are going to say, yeah, I'm all over putting sealant in there for you, big shooter. It's not going to happen, okay?
Yeah.
It can happen. It's a viable approach. I found, from my experience, the key to having success
Yeah.
is minimize the amount of work that interferes with the framing process.
Yeah.
Get the building framed. Before the trusses come, make your air connections visible.
Just think about it ahead of time. It's all sequencing, right?
Even the framers, here's a quick example. If you have a garage, it's not part of your air barrier system, but you come down a sidewall, how do you transfer through the garage to the other sidewall? Well, that back wall
Yeah.
needs to be part of your air barrier. Here's an idea. Put 3/4 plywood, tape the joints. The homeowner gets a pegboard for all his tools, and you transfer the air barrier across. Just food for thought, right? This is what we need to do is feed the brain and think about it. And there's a few places on any build that you need to consider for that transition. Once that's learned, which is easy, it just needs to be done, this will all be successful.
Great. So, got our air barrier transfer. I noticed we have a raised heel truss here, or a special truss that we're actually, raising it up to get insulation continuity here.
That's correct, yeah.
Which is different than past practices.
It's a
where
planned approach. How much you're putting here, you raise your heel appropriately.
Which is
yes.
great, but it means you also have the air barrier transfer isn't coming up here, right?
No.
Yeah.
I do not need an air barrier in my vented attic, right?
Yeah.
And so this here Tyvek that I put on here, a synthetic sheeting membrane, is simply a function of a water resistant barrier. And it laps over the air barrier, which is also the water resistant barrier.
Yeah.
So the WRB is continuous, and the air barrier takes what I call a left turn at Albuquerque and heads this way, okay?
That's great. Well, it makes a lot of sense. I mean, you got rain screen primary control. The
bet.
face of that insulation sheds any water is going to get past it.
You know,
And
it's a little
Yeah.
bonus layer that comes into that, okay?
Separating your rain screen from your water resistant barrier like this, huge benefit for water control. Very little water, and if any does now, like you showed, it just drains back out.
Yeah, it's an excellent wall.
Yeah, and then this assembly, because we don't have a vapor barrier on the inside, if moisture somehow does get in during construction, let's say, or a leak gets in somewhere, then it can dry back to the inside. So we've provided that
And
buffer.
there's a space behind the insulation
safety.
also.
Cool. Let's talk about the window detail here. So I notice you've pretty traditional installation. You've got you're resting the window on the framing itself. You're not building a buck like we have seen for some assemblies.
And the idea is I wanted to bring the insulation and the window as intimate as possible for continuity,
Yeah.
okay? But one of the things that's neat to consider is this here window sill
Yep,
is intended with a waterproof membrane by code because there's the potential for water.
that's right.
And if I have this water now, would it be okay to send my water down the groove? I don't want to do that.
Don't really want to do that.
This is a backup system, not a primary system. Okay?
Yeah, unless you're, like,
That's a
showing
key
off,
difference. Yeah, it's just like, hey, check me out. No, you want to bring the membrane out to here. So any moisture that does accumulate here will trickle outboard as the same function as the wall assembly, the same function as here. Everything comes outboard. I didn't drain it down behind here and out the head.
Yeah. And I noticed you nicely sloped the insulation because it's easy to do that. We didn't slope the sill here, but you could, if you wanted to slope the sill, you could, right?
Yeah, you could. And one of the things that's really, really interesting, and I think changes are coming, where, I think the A440 and stuff is going to change a little bit, where the back angle is a requirement of many manufacturers now for these box type windows.
Yeah.
And it's fastened in through here, right? But these being typically about 1.25 inches high, they're high enough to resist the design pressures for residential assemblies where, you need 250 pascals to raise water an inch. So even if your seal was poor, you won't get water ingress for the air. So there's a lot of benefits.
Yeah, so we've got our rebate or non-flange window here. It'd be kind of a lot more difficult to detail if we had a flange sticking in here, right? So a rebate window really makes this a lot easier to keep the insulation up flush and tight.
It also allows the flexibility of coming in and out on the assembly.
Yeah.
It avoids the need that you have to route out for the flange assembly and all the rest of it, and your subsill drainage and the rest that comes in with that also. It's much easier using a rebate type window. But if we
wanted
still do
to,
it with
we
the flange,
could. Yeah.
no problem.
Yeah.
You can do that. I chose for this that I built for you, I chose this approach. I find it a nice way moving forward because of my flexibility of where I can place this in the thermal plane.
So I noticed we got a sill angle on this detail.
Yes.
That's a lot of window manufacturers are
That's right.
wanting this now for attachment, so you don't put a fastener down through the sill. We've got clips on the jamb and the head for that attachment. You could also do a backer rod and sealant there.
Absolutely.
Yeah.
You
Just
can
depending
do
on
that.
really your risk and how wet it's going to get. And,
The function of the install. When you don't have the back angle, you're relying on the integrity of that install.
Yeah.
Period.
Yeah.
With the back angle, I'm relying on physics.
Yeah.
And physics always wins, okay? But I want to go back with the clip.
Yeah.
There's an important point with the clip,
Yeah,
okay?
we should talk about
gets
the clips, yeah.
omitted or missed on many applications is the clips are a lovely thing. It's simple for the install. You plumb it up. This is really great.
Yeah.
However, you then install the rod and caulking here. If I don't get sealant behind these clips,
yeah.
then I'll have a blow bypass for air leakage.
Yeah.
So when you install these windows, what I like to do is I'll install the window with all the clips.
Yeah.
Then I'll go back and only put one screw on each clip.
Yeah.
Then I'll go back, I'll undo the one screw,
Yeah.
load it with sealant, put it back.
Nice.
Undo the one, load it with sealant, put it back. Then I'll load my backer rod and caulk it, and I'm assured to have that. So instilling simple process is extreme benefit because that can really be an unfortunate thing that could happen.
Yeah. One thing here too, I noticed we don't need a vapor control layer on the inside of this insulation here because we've got enough insulation on the outside, right?
Yeah.
And really we've got, all the ceiling finishes and everything else. So, and then our built up wood framing there. So yeah, so this makes it a lot easier than trying to cut out poly or spray foam into your rim joist. You just put bat in there just to match the same insulation level here. So
I got a question.
yeah.
You talked about the bat and all this down here, and we don't need vapor control, but we have vapor control here. And can you explain a little bit about the need for vapor control? And then on top of that, I have one other question.
Yeah.
I chose to use 5-inch.
Yeah.
Because I happen to have 5-inch. Okay.
Yeah.
But let's say I wanted to put 1.5 inches
Yeah.
on the outside. Okay. For this wall that I want to build. So between those two things, the vapor control and a reduced insulation out here. What's the deal?
Yeah. Great question.
Well, I just saw that it mattered but didn't matter, and I want you to clarify that so everybody kind of gets a sense of that because, well, I want to know.
Yeah. Yeah. So the need for vapor control on the inside of this assembly with exterior insulation depends on the ratio of the exterior insulation to the cavity insulation, right? And
what climate zone you build in?
So and it's not only that the ratio, but also it's exterior conditions, but also interior conditions. So how humid it is, particularly in the wintertime, at the design conditions. So say it's -20 outside and it's 40% humidity on the inside, then you're gonna need a certain amount of insulation. If it's higher humidity, then you're gonna need even more insulation. So tends to be the colder it is and the more humid it is indoors in the wintertime at those cold temperatures, the more insulation you need. What we've generally found, in the past, we talked about 2/3 on the outside. So, if we had R20, we'd have, R30 on the outside. That'd be a safe ratio. So 2/3, 1/3 rule. Generally 50-50 for most construction or most climates, but also most occupancies, 50-50 will work. And once you sort of exceed that threshold, then you actually really don't even need much of vapor control, if any, on the inside. So it's great that you showed the vapor barrier paint, but the interesting part is you really don't need that vapor barrier paint even with the ratio here. You'd only really need it if you had, say, 1 inch or 1.5 inches of insulation. So it's nice you showed it because we can talk about this, but with this ratio here, you're actually set up that you have enough exterior insulation that the interior vapor control need drops. And this is talked about in the guides in a lot of detail, looking at the type of insulation you have, the R value ratios, and then all these things we talked about, like where is your air and water control layer in this assembly. So because we've got enough insulation on the outside, we don't really need a vapor control on the inside for most occupancies. Now, if we had a high humidity indoor environment, or we didn't have quite the ratio, then we would potentially look at doing that. Now, down here, we got a bit more insulation. So the ratio's a bit skewed. Although, so if you look
what
at this,
about a smart barrier just down here?
yeah, you could spend the time cutting it out and putting it in with.
Well, I tape it to the foam and.
What about just a small piece of foam? Foam's a good vapor retarder, so you could put 1 inch of foam in here, just some scraps that you had left over from outside, shove it in there.
Sure.
The reason we use bat in here because it's cheaper than foam, right? So.
Yes. No, my question was on the vapor control.
Yeah.
And that understanding of the ratios.
Yeah. I want to talk a little about the EPS in this wall. So we've used EPS, which is expanded polystyrene, and it's not completely vapor closed like a faced polyiso, and it's not as vapor impermeable as extruded polystyrene or XPS. And so when it's thin, like 1 inch of EPS would be around 3 perms. So it's not completely closed off. And so there are assemblies where you could actually put a vapor barrier with, say, EPS, and you'd still be okay with the code. Although what we find is you're getting pretty low, and as the thickness increases, especially 5 inches here, this is impermeable. And so once this is impermeable or pretty close to impermeable, that's really where you want to be much more careful with the vapor control on the inside. Now the good thing is, as we increase the thickness of insulation, that sheathing really never gets that cold anymore, and therefore the risk of condensation or high humidity in there is really, stopped.
Yeah, it just stays above dew point.
Yeah.
I'm a bit concerned. I mean, if you put a single layer on,
Single
what
layer.
about gaps?
Yeah.
And the potential, and that's why I was leaning towards a smart barrier on the inside.
Yeah.
I don't think it's detrimental. I'm not sure if I'm incorrect there, but you maybe can enlighten me. But, if you wanted to, like we have a lot of outside conditions that are redundant, would it make sense to consider a smart barrier on the outside until you got to, you know, extreme exterior insulation.
Yeah, I mean, the vapor retardant, the smart vapor retardants in particular on the inside are going to keep any of that vapor from going through.
Right.
But if it needs to dry out through, you can get some drying inwards. With the ratios you have here, the likelihood of air leakage condensation is quite minimal. Actually, once you add any exterior insulation, the risk for air leakage condensation drops, right?
Yeah.
And so in BC, we're really fixated on rainwater, and that's why, you know, if water does get in there, having that high ratio keeps it warmer and then speeds up the drying, actually. And having that vapor openness on the inside allows that drying to occur.
Mm-hmm.
You know, it's kind of like the scenario, if you had plastic on one side and it was closed off on this side and water did get in, the humidity just builds up in there and it can't go anywhere. And that's the fear that I think some builders have. So this assembly here has that buffer on both sides and allows you to use, you know, a lightweight, you know, low cost rigid insulation. The other thing I want to talk about with Wall 3 here is this assembly allows you to use really any type of foam plastic on the outside. Foam plastic, EPS, XPS, fixed polyiso can all be used in this scenario here. And it doesn't have to, the material itself doesn't have to be tested as an air barrier or water resistant barrier, right? So when we talked about Wall 2 with the XPS, the surface of that insulation was taped and sealed, and those manufacturers had gone through the testing to prove in Canada that it will be a long-term air and water resistant barrier. Mm-hmm. This approach allows you to use any type of insulation that's suitable for exterior application over a traditional house wrap.
Yep.
And the unique thing here, you either drainage with drain mat or drainage with drainage groups.
Okay, so it functions well, and my takeaway here is it's a good wall, and be cognizant of the ratios that you use on this type of wall, and plan accordingly.
That's great. That's a great summary. Yeah, this wall can work quite well, and it's well thought out. I think that the key thing here is you're thinking about the insulation ratio, the water control, and the air control behind the insulation. The vapor control is sort of thought out when to have the buildup of the insulation, and the guides walk you through all the details. It walks you through all these details from the roof to below grade and through a window, and really hits on the points of what we're looking for here. And I think for builders, more insulation in this assembly is always going to be safer, especially as you're starting to use double layers and staggers for even keeping more of the water out. But it's the thinner amounts of insulation that you really have to think about. So if we're shooting to R30 or R35 to 40, getting a lot safer. Now, one thing you could do to improve that ratio is you go back to a 2x4 instead of 2x6.
Well, we'd use 2x6 now just to satisfy, well, in British Columbia, our building code requirement. It's not a structural requirement in most cases.
Yeah. So as a builder, if you had a client that wanted this window to be flush with the outside to match that older or the aesthetic that they're used to, what would you do in this assembly?
I'd have to integrate a structural buck around the window.
Yeah, you couldn't put the window on the styrofoam, right?
No. You can't do that, okay? Ever pick up a triple glazed window,
I know.
okay? It's a serious load, okay? And it needs to be structurally supported, and those loads need to be transferred through your structure.
Yeah.
Okay, it's a requirement.
So we're going to build a buck?
And so we're going to build a buck structurally that can take and transfer those loads to the building itself and carry the load down. And there's lots of ways to do that.
And if I had a buck, what would I do if my water control layers run into that buck? Probably want it sloped, right?
Yeah, on the slope buck itself.
Yeah.
So I want to carry my barriers through my structure, because from the sequence of construction, that makes it simple. Okay? You can put all your barriers on and then add to it. Okay? I'll still integrate drainage above it, but I'm going to carry it through my buck. And the idea is to keep it simple. Don't have so many transitions. Cover the building with the control layers, and then build on top of that.
Yeah. This has been a great overview of Wall 3. Thank you very much, James.
No, you're welcome. Came from the guide. I read the guides, and that's why I asked the questions about the bottom, because I wanted to talk about those ratios and stuff, because you got to read the guides, you got to understand it, and it can be very, very successful.